Who was Theodore Kaluza? Theodore Kaluza lived from 1885 through 1954, was a German mathematician and physicist with interests in general relativity. In 1919, he sent Albert Einstein an unsolicited paper proposing a radical idea. What if the universe had not four but five dimensions? Four of space-time and one extra spatial dimension. And what if electromagnetism was actually just gravity leaking into this fifth dimension? What paper did Kaluza send to Einstein in 1919? The title of the paper, published later in 1921, was Zum Unitätsproblem der Physik, on the unity problem of physics. Kaluza proposed extending Einstein's general relativity to five dimensions, where the five-dimensional metric tensor, a mathematical object that describes gravity, would not only account for gravity, but also produce Maxwell's equations of electromagnetism when compactified. Einstein's reaction? Einstein was intrigued but cautious. Initially, he thought the idea was mathematically elegant but physically speculative. He was unsure what to make of the fifth dimension. Was it real or just formal? Eventually, Einstein did present Kaluza's paper to the Prussian Academy of Sciences in 1921, lending it credibility, but he remained ambivalent for years. Einstein's response was respectful, but he struggled with the physical meaning of the fifth dimension in the absence of the electron in the theory. So why five dimensions? And what's this business about the five-dimensional space-time metric having 15 components? Indeed, in a five-dimensional space-time, the metric tensor has 15 independent components, since it's symmetric. So, Kaluza's insight really was that gravity plus electromagnetism plus a scalar field equals five-dimensional gravity. He essentially geometrized electromagnetism, putting it on the same footing as gravity. A stunning unification idea. Oscar Klein gives an interesting contribution in 1926. Oscar Klein, a Swedish physicist, made the theory physically meaningful by proposing the fifth dimension is compactified, curled up into a tiny circle so small that we don't notice it. He proposed that this extra spatial dimension has a compact topology, like a circle, of a radius about 10 to the minus 33 centimeters, or the Planck length. Klein's insight is that the five-dimensional spacetime is effectively four-dimensional at low energies. The electromagnetic field arises from motion or vibration in this hidden circular dimension. Particles like electrons might have momentum around the circle, giving rise to quantized charges. This became the origin of the idea of extra dimensions in string theory and modern physics. Problems, however, arose with the Kaluza-Klein theory. Despite its elegance, the original Kaluza-Klein theory faced serious issues. Electron charge to mass ratio. The theory didn't naturally explain why the electron has the charge to mass ratio that it does. There was no explanation for discrete electric charge values or quantization. The scalar field. The component G55 predicted a massless scalar field, sometimes called the radion. No such field was observed in experiments. Physically, it was unclear what this scalar field was. There was also the issue of no source for electromagnetism. The theory predicts the electromagnetic field, but it does not include charged matter, for example, electrons, as sources. There were other instabilities and inconsistencies. Later quantum field theory showed that simple Kaluza-Klein models are unstable or inconsistent when extended beyond classical limits. Now, there is a legacy and even a modern revival of this theory. Though flawed, Kaluza-Klein theory was the first real attempt at unification and inspired string theory, which requires 10 dimensions in its 5 supersymmetric flavors, and unifies gravity with all other forces using vibrations in compactified space. Supergravity and M theory also extend these ideas using supersymmetry and higher dimensional branes. Now, the brane world models also explore scenarios where standard model particles are stuck on a four-dimensional brane in higher dimensions. So Einstein himself revisited Kaluza-Klein-like ideas multiple times in his later years, still searching for the one geometry that unifies everything.